Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today we have set our hearts to solve a paper 1 of this subject. And the paper 1 is related with the MCQ questions. And for this purpose, we have selected May-June 2025 1-2 paper. This paper 1 belongs from the Zone 2. The time allowed for this paper is 1 hour, and there are 40 MCQ type questions in it. So let's start today's work. So on your screen, the paper is showing up. The one very important thing is that this paper and the marking scheme which I am using in this video, they are the property of the Cambridge Assessment International Education. I have only downloaded them, the paper and the marking scheme, and I am presenting you the solution of this paper to the best of my knowledge, my abilities, and my skills. So the paper and the marking scheme are the property of the Cambridge Assessment International Education. So let's start today's paper, 505412, May-June 2025, the paper 1, the multiple choice paper. And here we go. There are total 40 questions in it. The question number 1 is coming up on your screen. Okay, in the question number 1, they say, which list contains only vector quantities? Vector quantities are those quantities who have the magnitude and direction. So mass is a scalar quantity, so A is not the answer. B is the momentum. Momentum has direction, gravitational field strength, and displacement. Okay, so the momentum has direction, gravitational field has direction, and displacement has direction. C is energy, force, velocity. Energy does not have direction. D is acceleration, time, and speed. Speed and time do not have direction. So B, I think the B is the right answer, sir, because in the list B, all the quantities, they have direction and magnitude. So the answer is B. I hope you understand. The question number 2 is showing up on your screen. Okay. The question number 2. The diagram shows the distance time graph for a moving object. So this is a distance time graph. On the y-axis, the distance is represented. On the x-axis, the time is represented. What is a description of the moving object? You see, here the gradient is constant, and then the gradient is decreasing, and then the gradient has become 0. The gradient of the distance time graph represents the velocity or the speed. Okay, so it was moving with a constant speed, then the speed decreases, and then the speed becomes 0. That's the slope, the gradient of this graph is equal to the speed. A ball thrown vertically upwards and falling back to the ground. A car starting from rest and speeding up as it moves away from a traffic signal. A rock dropped from a high cliff and falling to the sea below. A train braking to a halt as it stops at a station. So I think this is the right option, sir, the D1. And wow, the reason is simple. You see the speed here, the speed is constant, then the speed is decreasing, and the speed becomes 0. The gradient of this distance time graph is equal to the speed. So on the basis of this, the gradient, I'm talking about the speed. So I think it's D choice, a train braking to a halt as it stops at a station. Okay. So the question number 2, the D is the right option, I think. Question number 2, D is the right option, sir. A ball thrown vertically upwards and falling back to the thrower. The distance should increase and the distance should then decrease. A car starting from rest and speeding up as it moves away from a traffic signal. If it only speeds up, then the gradient should be increasing. A rock dropped from a high cliff and falling to the sea below, then the speed should be increasing, not decreasing. Here, the gradient has decreased. The speed should be increasing like this, okay? So D is the right choice, sir. Question number 3 is showing up on your screen. He says the speed time graph for a falling skydiver is shown. As he falls, the skydiver spreads out his arms and legs and then open his parachute. Which part of the graph shows the skydiver falling with the terminal velocity? So here we have a speed time graph. The terminal velocity is when the speed becomes constant. The upward and the downward forces, they become equals to each other. And you see what happens, that the resultant force becomes zero, acceleration becomes zero, speed becomes constant. So here the speed time graph has become horizontal, which means the speed is constant. So I think at the D, we have the terminal velocity. Question number 3, D is the answer, sir. Okay. Okay. Here we go. A car, question number 4, a car driver traveling at constant speed in a straight line sees a hazard in the road ahead at the time equals to 0. The speed time graph shows how the speed of the car changes from t0. This is a speed time graph. This is the thinking distance. This is the braking distance. 3 students suggest what area X and area Y represents. Student 1, area X represents the thinking distance. That is true. The student 1 is correct. And student 2, area Y represents the stopping distance. That is wrong. Student 3 says that the area X plus the area Y represent the stopping distance. That is true. Okay. So, and this is the thinking distance. This is the braking distance. When you add them up, this is the stopping distance. So stopping distance is equals to the thinking distance plus the braking distance. Okay, which students are correct? I think that the 1 and 3, they are correct. So I think the B is the choice. B is the right choice, sir. I think question number 4, B is the right choice, sir. I hope you understand. Okay, so on your screen, the question number 5 is going to show up. Okay, on your screen, question number 5 is showing up. He says that the diagram shows a graph of the load against an extension for a material. At which point is the limit of proportionality? Up till point A, you can see the graph is a straight line between the load and the extension, which means the load and the extension, they are directly proportional to each other. After that point, the graph has become curved. So this point is the limit of proportionality. So this point is the limit of proportionality. We think question number 5A is the right option, sir. Question number 5A is the right option. Okay, so we are going to the next question. The next question coming up on your screen is question number 6. Okay, question number 6 is there is no atmosphere on the moon. Two metal spheres of the identical volume but different mass are at rest at the same height above the ground on the moon. The two spheres are dropped at the same time. How does the sphere move after they are dropped? You see, because on the moon, there is no atmosphere. If you will have bodies of two different masses, if you will drop them, and because there is no atmosphere, because there is no air, because there is no air resistance. So what will happen? That they both will gain the same acceleration and they both will hit the ground at the same time. So this is a very, very famous concept. If there is no atmosphere or there is no air resistance, if you drop the body, two bodies which have different mass, they will have the same acceleration and they will hit the ground at the same time if you have dropped them from the same height. Question number 6, I think the two spheres hit the ground together. I think the D is the right wording. Question number 6, I think D is the right word. The two spheres hit the ground together. A option is the sphere with the larger mass has a smaller acceleration. That's wrong. The sphere with the larger mass hits the ground first. No. In the absence of air resistance, this does not happen. The sphere with the smaller mass has a smaller acceleration. That is also wrong. They both will have the same acceleration. So we think question number 6, and it's D is the right option, sir. Question number 6, D is the right option. Okay, so on your screen, the question number 7 is now showing up. Question number 7. Okay. Our student determines the density of a small rock. The weight of the small rock is 1.2 Newton. She pours 100 centimeter cube of the water into a measuring cylinder. She carefully submerges the rock in the 100 centimeter cube of water. The new reading on the measuring cylinder is 147 centimeter cube. What is the density of the rock? You see, to find out the density of the rock, I need two things about the rock. I need to know the volume of the rock and I need to know the mass of the rock. The weight of the rock is given, so very easily you can find the mass of the rock. W is equals to mg. M will be equals to W divided by G. The G value is 9.8. And then we need the volume of the rock. The volume of the rock here, they are going to find because they have used the measuring cylinder. And when you submerge the rock, the volume of the water is 147, and without the rock, the volume of the water is 100 centimeter cube. When you subtract them from each other, you get the volume of the rock. So let me show, I have done this, and here on your screen that's showing up. So volume before the rock is submerged is 100 centimeter cube. The volume after the rock is submerged is 147 centimeter cube. So the volume of the rock will be V2 minus V1. So that's 147 minus 100. That is 47 centimeter cube. The weight is equals to mg. The m is equals to W by G. 1.2 divided by 9.8. That is 0.122 kg. So let me convert this into grams. To convert into gram, you have to multiply with 1000. So you will get 122.45 gram. Now the density is equals to the mass divided by the volume. So it will be 122.45 divided by 47. And that will be 2.6 grams per centimeter cube. 2.6 grams per centimeter cube. So we think that D is the option, sir. 2.6 grams per centimeter cube. This is how this is this numerical is solved. Question number 7, D is the right option, sir. This is how this is done. Question number 8 is showing up on your screen. He says, a rock of mass 20 kg is traveling in space at a speed of 6 meters per second. What is the kinetic energy? You see the formula for the kinetic energy is 1 by 2 mv square, where m is the mass, v is the velocity. And you simply have to put those values into that formula, and you will be able to calculate the kinetic energy. So the kinetic energy is basically equals to 1 by 2 mv square. And so this will become 1 by 2 into 20 into 6 squares. That will be 360 joules. 360 joules. 360 joule. I think the C is the right answer, sir. 360 joule. Question number 8. C is the right option, sir. I hope you understand this. Okay. So we are done with the question number 8. Now we are going to the next question. That is question number 9. Okay. Which row shows an advantage and disadvantage of using nuclear fuel to generate electric power? The advantage of the nuclear fuel is that it do not produce carbon dioxide. Okay, so that it do not produce the greenhouse gases. And what is the disadvantage? The disadvantage is that the waste of the nuclear reactor is very radioactive. So advantage is does not produce carbon dioxide, and disadvantage is produces radioactive waste. The A is the best answer, sir. Does not produce carbon dioxide. Okay, only works in some weather condition. That is not right, sir. The nuclear reactor is available you 24/7. Energy source is renewable. The radioactive is not, and the nuclear reactor is not a renewable energy source. So the nuclear energy is not a renewable energy source. So I think question number 9, the best option is question number A is the right option, sir. So let's say question number 9A is the right option, sir. So on your screen, the question number 10 is now showing up. Which row gives the definition of the work done and the unit of the work done? The definition of the work done is that the work done is the force multiplied by the distance moved in the direction of the force. and its unit is always joules. Okay, this is the basic definition of the work done. Work done is the product of the force and the distance traveled in the direction of the force, and the unit of the work done is joule. So I think C looks the best option to me, sir. C. Let's check. Question number 10. Question number 10, C is the right option. So the unit of the work done is joule, and the definition of the work done is the force multiplied by the distance and moved in the direction of the force. A hammer hits a nail. This is question number 11G. A hammer hits a nail into a piece of wood. The weight of the nail is negligible. The hammer exerts a force FH and a pressure PH on the nail. The nail exerts a force of FW and a pressure of PW on the wood. How do these forces and the pressure compares? The forces will be same. That's a simple conceptual thing. That the force the hammer applied, the same force the nail applied on the wood, but the pressure will be different. You see, when the hammer applies that force on the nail has a head and its contact area will be larger. But when the nail will apply the same force on the wood, the contact area is the tip of this nail, which is very small. So the pressure which is created on the wood, that will be larger than the pressure which is created on the head of the nail. But the forces will be same. It's a conceptual thing, sir. Question number 11, I think A is the right statement. The forces, both forces will be equal, but the pressure which is created on the wood, that will be much greater than the pressure which is created on the head of the nail. Question number 11, we think A is the option, sir. That is right option. Okay, question number 12 on your screen. The pressure at a point beneath the surface of a liquid varies with the depth of the point and with the density of the liquid. Which changes both increase the pressure beneath the surface of the liquid? You know, when the pressure is equals to the rho and G and H. Okay, so the pressure depends upon the density of the liquid, the pressure depends upon the gravitational field strength, and the pressure depends upon the depth of the liquid above the point of observation. The change in the depth, if you will increase, we are looking for how to increase the pressure. So increase the depth and increase the density. So if both these things will increase your, okay. So I think D is the right option, sir. Increase the depth, that will increase the pressure of the liquid. Increase the density of the liquid, that will also increase the pressure of the liquid. This is how you do question number 12. I think D is the right option. And let me check, sir. Question number 12, D is the right option, sir. Question number 13 on your screen. The diagram shows a cylinder containing air and the piston is free to move inside the cylinder and atmospheric pressure acts outside the cylinder. So as the air inside the cylinder is heated, the piston moves to the right, which quantity decreases. So he says the diagram shows a cylinder containing air. The piston is free to move inside the cylinder and atmospheric pressure acts outside the cylinder. As the air inside the cylinder is heated, the piston moves to the right, okay? Which quantity decreases? The average force exerted on the piston each time that one air particle hits the piston. The average speed of the air particles, because you are heating it, the average speed of the air particles should increase. The mass of the air inside the cylinder, that should not change. And the number of the collisions made by particles with the piston in 1 second. Which quantity decreases? I think the number of the collisions per second, because their kinetic energy has increased, but their pressure will not increase, okay? overall pressure will not increase. So what will happen? The number of collisions made by the air particles with the piston in 1 second, that should decrease to keep the pressure same. Because here the pressure is kept constant. The inside pressure and the outside pressure will be same. As you heat it, this piston will move. Outside you have atmospheric pressure. This will keep on getting out towards the right until the inside pressure and the outside pressure is equal. So the pressure is constant. Okay, so the volume has increased, you have increased the temperature, the volume of the gas has increased. So but the gas molecules have started moving faster, but their uh, collision frequency has decreased. So I think D is the answer, sir. Question number 13. D is the option, sir. I think question number 13, sir. D is the right option. Okay. Question number 13, D is the right option. Then we have question number 14 coming up on your screen. Okay. He says a fixed mass of air has a volume of 150 centimeter cube and a pressure of 120 kilopascal. And the volume of the air is now changed to 100 centimeter cube. The temperature of the air remains constant. The temperature of the air remains constant. Okay. So this is very important. When the temperature of the air is constant, we can apply the formula P1 V1 is equals to the P2 V2. What is the new pressure of the air? So it's a classical question for this equation. P1 V1 is equals to P2 V2. So 120,000 multiply 150 equals to P2 into 100. So make the P2 alone. So you will have 120,000 multiply 150 divided by 100, and you will have 180,000 Pascal. So I can write it 180 kilopascal. 180 kilopascal, 180 kilopascal. So I think D is the option, sir. Question number 14. Sorry. This is not the option, sir. 180 kilopascal is here. This is wrong. This is not the answer, sir. This is not the answer. Let me. This is not the option. Okay. The right option is this 180 kilopascal. Question number 14. I think B is the option, sir. Question number 14. B is the right option. By mistake, I shaded this. 180 kilopascal. This is how you will do it. I hope you understand this. Kilo means 1,000. Okay, so we are going to the next question. The next question coming up on your screen is question number 15. And it says the diagram shows 4 changes of state W, X, Y, and Z. Okay. So the W is liquid converts into gas, that is called boiling. X is the gas converts into the liquid, that is called condensation. Y is the solid converts into liquid, that is called melting. And Z is that the liquid converts into the solid, that is called freezing. So this is basically boiling, condensation, and melting and freezing. So what is the option, sir? What is the option? I think D. Question number 15, I think D is the right option, sir. That is true, sir. Question number 15, D is the right answer. Okay. So now on your screen, we have the question number 16 showing up. Okay. The diagram shows a metal pan on a hot plate. So this is a metal pan. This is a pan. This is a hot plate, the water inside it. The pan is heated by the hot plate. How is the thermal energy transferred through the hot plate to the metal pan? And very simple, they are solids, so the energy through the solid is transferred by the conduction. So I think that question number 16A is the right answer, sir. It's a very famous concept. Through the solids, the heat is transferred by the process of conduction. Question number 17. A beaker of cold water is heated at its base. What happens to the heated water? So when the water will be heated, what will happen to the density? The density will decrease, and movement of the heated water, they will be moving in upward direction because of the convection currents. The density will decrease and they will move upward. I think B is the option. Let's check. Question number, which question was 17? B is the right option, sir. The graph shows at one instant the pressure variation along a sound wave. Okay. So this is the pressure variation. The pressure is on the y-axis, and here we have the distance. So at which point the diagram represents a rarefaction and what is the wavelength of the sound? The rarefaction is when the pressure becomes negative. So the pressure is negative at the Q, so this represents the rarefaction. And the wavelength is because on the x-axis the distance is represented. So from one peak to the other peak, from one crust to the other crust, we have this x. So the wavelength is x and the rarefaction is at the point Q. So I think question number 18, I think C should be the answer, sir. Question number 18, C is the right answer, sir. At the rarefaction, the pressure goes negative. Question number 18, C is the right answer, sir. This is the wavelength, and this is positive pressure, so that is compression. This is negative pressure, that is rarefaction. Question number 19 is showing up now on your screen. Okay, he says that a cork on the surface of water moves up and down as a wave passes across the surface. The diagram shows how the height of the cork above the average level of the surface varies with the time. So if you look at this graph, on the x-axis, the time is represented from, and on the y-axis, they have represented the height. So from this, I can tell the amplitude, and from the x-axis, I can tell the time period. The numerical value of the wavelength of the wave, the numerical value of the wavelength of the wave is equal to the numerical value of the amplitude. This sentence is very, very important. Just highlight this. Okay. This sentence is very important. He said, from this graph, you cannot tell the wavelength directly. From this graph, you can tell only the amplitude of the wave. But he said the numerical value of the wavelength of this wave is equal to the numerical value of the amplitude of this wave. So the amplitude here is 2 centimeters. So that means the wavelength is also 2 centimeters because of this sentence. The time period and the time in which this wave is completed is 0.5. So once you know the time period, you can calculate the frequency. The frequency is equals to 1 by t, the reciprocal of the time period. Let me show you. I have done this on here, question number 19. Okay, question number 19 is showing up. The paper we are doing is 505412 May, June 2025. So the code of this subject is 5054. This is Cambridge O levels physics. It's paper 1 from the zone 2. And this is from the exams of the May, June 2025. I'm presenting you the solution of this paper. So question number 19, the wavelength is equal to the amplitude that is given in the question. So the lambda is 2 centimeters. The time period of the wave from that graph I can tell is 0.5 seconds. Frequency is equals to 1 by time. So time period, so 1 by 0.5, that is 2 hertz. Now we can apply the formula for the speed. V equals to F lambda. We call this wave equation. So the frequency is 2 hertz and the lambda is 2 centimeter. So when you multiply them, you get the speed that is 4 centimeter per second. 4 centimeter per second. Do we have that in option? So C is the option, sir. C is the option, sir. Question number 19, C is the right option, sir. This is the numerical solution, how this is done. You can pause the video to take your time with this if you want more time with it. Question number 19, C is the right option, sir. So question number 20 is showing up on your screen now, that a water wave travels from deep water to shallow water in a ripple tank. What happens to the speed and to the wavelength of the wave? In the shallow water, the speed is slower as compared to the speed in the deep water. And in the shallow waters, the wavelengths are smaller as compared to the wavelengths in the deep water. So the speed of the wave as you go into the shallow water, and the speed will decrease and the wavelength will also decrease. This is a basic concept. Question number 20, D is the option, sir. This is about the water waves. D is the right option, sir. In the shallow water, the speed is slower and the wavelengths are smaller. The diagram shows a ray of light directed at a plane mirror. So this is your plane mirror. This is the right. This is the incident ray. It is making 40-degree angle with the surface of the mirror. What are the angles of incidence and the angle of reflection? So let me show you. I have done this. Okay. So here you have to draw a normal. So what you will do, you will draw a normal here. Normal is a line which makes 90-degree angle with the surface of the mirror. So the angle between the normal and the incident ray, that is called the angle of incidence. So the angle of incidence will be equals to, the angle of incidence will be equals to 90 minus 40. 90 minus 40. So the angle of incidence will be equals to 50 degree. The angle of reflection and the angle of incidence, they are always equals to each other. So the angle of reflection will be also 50. So 50, 50. So 50, 50. So I think D is the option, sir. I think D is the right option. Sir, this is question number 21. I think D is the right option, sir. Question number 21, D is the right option. Okay, so we are going to the next question, and the next question coming up on your screen is question number 22. Question number 22. Question number 22. A ray of light in glass is incident on the surface at an angle of C. The angle C is the critical angle, which diagram shows what happens to the light. Angle of incidence is the angle of incidence in the dense medium, for which the angle of refraction in the rare medium is of 90 degree. So in this here, the angle of refraction is not 90, not 90, not 90 here. Here you can see the angle of refraction is of 90 degree. So I think the D is the option, sir. Question number 22. Question number 22, D is the right option, sir. I hope you understand. The angle of incidence is called a critical angle, and the angle of incidence will be in the dense medium, for which the angle of refraction in the rare medium will be of the 90 degree. And that is so that angle of incidence is called the critical angle. So question number 22, D is the option, sir. Question number 22, D is the right option. So let's go to the next question. The next question on your screen is the question number 23. Here, let me show you. Here question number 23 says an object O is placed between a converging lens and one principal focus of the lens. Between a converging lens and one focal. Okay, so let me show you. So what is their question? Their question is, what is the magnification of the image form? So first of all, we have to form the image here. So when we form the image, so what we do, we draw two rays. The first ray starts from the head of the object, goes parallel to the principal axis, then passes through this F on the other side. Then you prolong it behind. The other ray starts from the head of the object, passes through the optical center, okay, and then you prolong it behind. These prolonged lines behind this object here, where they intersect, the image is formed. That image will be a virtual image. That image will be a magnified image. We say that the convex lens is being used as a magnifying glass. If you want to find out the magnification, there can be two things: the height of the image divided by the height of the object, or you can write that the distance of the image from the lens, which we call normally V, and divided by the distance of the object from the lens, that we normally call U. So let me show you. I have done this on your, to show you how this is done. So you can see this here. I started a ray from here, came here, then went to this F. I prolonged this ray behind, and the other ray starts from the head of the object, passes through the optical center, goes like this. I prolonged it behind. So where these prolonged dotted lines intersect with each other, there the image is formed. Now you can see the distance of the image from the lens is 6 centimeter, and the distance of the object from the lens is only 2 centimeter. So magnification will be V by U equals to 6 by 2, that is 3. So the magnification is 3. So I think C is the option, sir. This is the question number 23. We think that the C is the right option, sir. This is how this is done. And let me show you the whole question together so you can have a better sense of this question. I hope you have a hard copy of this paper with you. If you have the hard copy of this paper, you can do this. Okay, on your paper, then it becomes much easier. Okay, now we are on the question number 24. Question number 24. Which statement about red light and violet light is correct? A prism deviates the red light more than it deviates the violet light. So if you remember, the code word, let me write this. The code word is red and orange. Orange, and then you get yellow, and then you get green, then you have blue, and then you have indigo, and you have violet. This is the order of those colors. Okay. So this is how they are banded. Okay. And this is the order in the spectrum. This is when the light passes through a prism, the band of colors is formed, and this is the order. As you go down in this order, the wavelength decreases and the frequency increases. So red is the least deviated, and violet is the most deviated. The prism deviates red light more than it deviates the violet light. That is wrong. The red is deviated less, okay? Red light has a lower frequency than the violet light. Yes, that is true. The violet light will have, in this order, if as you go down, the frequency increases. So the red light has a lower frequency than the violet light. That is true. So red light has a shorter wavelength, and that's wrong. As you go down, the wavelength decreases. Okay. The speed of the red light in a vacuum is less than the speed of the violet light in a vacuum. That's not true. Both the colors will have the same speed in the vacuum. So the red has a lower frequency The red has a lower frequency, you know. So I think B is the option, sir. Question number 24. Question number 24, B is the option. Question number 25, ultrasound is used to clean jewelry in a liquid. What is another use of the ultrasound? Ultrasounds are used to clean the jewelry. Ultrasounds are used for prenatal scanning, a very, very famous use of this. So question number 25, I think B is the option, sir, which is the right answer, sir. Question number 26, showing up on your screen. He says a ship is stationary on the surface of the sea, sends pulses of the sound vertically downwards towards the seabed. Each pulse that reflects from the seabed is received 1 second after it is sent out. A whale swims under the boat and a pulse is received 0.60 seconds after it is sent out. The speed of the sound in the seabed, seawater is 1500 meters per second. What is the distance of the whale above the seabed? You see, very easily we can find the depth of the seabed. That is the speed of the sound in the water, multiply with the time in which the signal goes and comes back, and then you divide it with the two. And the depth of the whale will be the speed of the sound wave in the water, multiply the time the signal took to go and come back, and then you divide it with the two. Once you have both the depths, then you can subtract them from each other. You will find how much the the seabed is deeper than the depth of the whale. This is the question. What is the distance of the whale above the seabed? This is the question, sir. Question number 26. Let me show you. I've done this on a paper. So let me show you. Okay, so here we go. Question number 26. Depth of the seabed will be 1500 multiplied 1 divided by 2. That is 750 meters. So the seabed is 750 meters. Depth of the whale will be 1500 multiplied 0.6 divided by 2. And that will be 450 meter. Now the depth of the bed of the sea and the depth of the whale, subtract them from each other. This will give you the distance between the seabed and the whale. And that is 750 minus 450, and that is 300 meters. So 300 meter, I think, is the answer, sir. Question number 26A is the option, sir. Question number 26A is the right option, sir. And this is how this is solved. If you want more time with this, you can pause the video. Question number 27. Which road describes ultrasound? Ultrasounds are longitudinal waves and their frequency is more than 20,000 hertz. It's a very famous concept. Simple. The type of wave is longitudinal and the frequency should be greater than 27. B is the option, sir. Question number 28. So here we have question number 28. A quantity is defined as the work done by a source in moving unit charge around the circuit. What is the quantity and what is its unit? This is the definition of the EMF of a battery. So this is electromotive force and its unit is volt. 12-volt battery, 6-volt battery, 1.5-volt cells. This is their EMF and its definition is the work done by the battery to move unit charge in a circuit. That is equals to the electromotive force of that battery. So question number 28, electromotive force and the unit is volt. I think B is the option, sir. Question number 28, B is the right option, sir. This is a very, very famous definition and it's such an easy MCQ. So question number 29. A student connects the circuit shown. The switch S is closed. What is the reading on the voltmeter? If you look at this circuit carefully, you see, so from here, the conventional current will come 3 ohm resistor. Then these 6 and 6, they are connected in parallel to each other. And then again, you have a 6 ohm resistor, and then it goes back. The voltmeter is connected across this 6 ohm resistor. The switch is closed. What is the reading on the voltmeter? Okay, so we have to tell how much is the voltage drop on this 6 ohm resistor. So, we can calculate what is the total resistance of this circuit. First of all, find the equivalent resistance of these two. Once you know the equivalent resistance of these two, let me call that this R5. Then you can add 3 and R5 and this 6, and you will have the total resistance of this circuit. Once you know the total resistance of this circuit, you can calculate the current coming from the battery. The current coming from the battery, this formula is EMF of the battery divided by the R equivalent, the total resistance of the circuit. Once you know the currents, okay? So the amount of the current which come out of the battery, same amount of the current goes back to the battery. So all the current is passing through this. So once I know that current, I know the resistance here, I can calculate how much is the voltage drop on this 6 ohm resistor. So let me show you, I have done this on a paper. Here we go. First of all, you see the 1 by R5 will be equal to 1 by R2 plus 1 by R3. 1 by R5 will be equal to 1 by 6 plus 1 by 6. So 1 by R5 will be equal to 2 by 6. So R5 will be equal to 3 ohm. Then that R1, R3, and the R4, they are in series with each other. So their sum will be 3 plus 6, that is 10 ohm. So the total resistance of this whole circuit will be 12 ohm. The current coming from the battery, that will be EMF divided by the R equivalent, that will be 6 divided by 12, that is 0.5 ampere. So the current coming from the battery is 0.5 ampere. The current, the amount of the current which come out of the battery, same amount of the current goes back to the battery. So V is equals to IR. I can tell the voltage drop on that last 6 ohm resistor. I know the current flowing through it. I know the resistance of this. So we can calculate the voltage drop there. 0.5 into 6, that is 3 volt. So 3 volt, 3 volt, 3 volt. Question number 29. 3 volt is the answer, sir. So B, I think question number 29, B is the option, sir. Question number 29, I think B is the option, sir. Question number 29, B is the right option, sir. Yeah, question number 30 showing up on your screen. He says two resistors connected in series act as a potential divider as shown. The resistors have a resistance R1 and R2, and the potential differences across them are V1 and V2 respectively. Which expression is equals to V1 by V2? Very famous expression. V1 by V2 will be equals to R1 by R2. It's a theoretical question. This formula is written in your textbook. V1 by V2 is equals to R1 by R2. This is the circuit for the potential divider as well. Question number 30, we think A is the option, sir. Question number 30, A is the right option, sir. Okay, sir. Question number now 31. There is an electric current of 1.5 ampere in a 4 ohm resistor. How much energy is transferred electrically to thermal energy in 1 minute? You see, the thermal energy is equals to IVT, and the time must be in the seconds. The form I should know the current. I should know the voltage drop. I can calculate the voltage drop. I know the resistance. I know the current flowing through it. So very easily we can find out the voltage drop. So first of all, I will calculate the voltage drop. This calculation will be done first. So 1.5 ampere multiply 4 ohm, then you get the 6 volt. Then I can calculate the energy. The energy is IVT, but the time must be taken in seconds. They gave us the time in 1 minute. They said the time is 1 minute. So in 1 minute, there are 60 seconds. So 1.5 into 60 into 6 into 60, that will be 550 joules. 550 joules, 550 joules, 5 sorry, I said 550. It's 540, sorry. 540 joules, 540 joules. So I think C is the option, sir. Question number 31. C is the right option, sir. Question number 31, C is the right option, sir. This is how this calculation is done. First of all, we did this calculation, then we did this calculation, and we came to know that 540 joule is the energy, electric energy. Then we have this question, the question number 32. Let me reduce this. A square coil is placed in a horizontal uniform magnetic field. The plane of the coil is perpendicular to the magnetic. The plane of the coil is perpendicular to the magnetic field. The coil is now rotated about an axis through the P at a steady rate. The coil rotates through 180 degree. The diagram shows how the electromotive force induced in the coil varies as it rotates through 180 degree. Remember, because this is a generator, so you are rotating the coil through 180 degree, not through 360 degree. So the EMF induced should show half the cycle. The EMF should show half the cycle, and alternating current will be induced and only half the cycle will be shown. So neither C nor D, they are out of the game. A and the B can be the options. Okay, now because you have only moved half the cycle of the rotation of the coil, so the direction of the EMF should not change. The direction of the EMF should either remain positive or it should totally remain negative. A is the right option, sir. I hope you understand what I am saying, because the coil has only moved through 180 degree. It has not completed its cycle. So that's a half cycle. So the alternating current induced should be showing half cycle. So only in A and the B, they showed half cycle. C and D, they are out of the game. So because in the half cycle, the direction of the EMF should not change. Either it should remain positive or it should remain negative. So B is out, A is the option, sir. We think that the question number 32, A is the right option, sir. This question is in the paper 1-1 of May, June 2025. They also gave this kind of question. So this concept is important, sir. Question number 32, A is the right option, sir. Show you that question again. So you can see, look at this graph. These are the, I'm just trying to show you because to see the whole question, we have to reduce the size. Now you can look at these options. And this was their statement. Okay. And these were the options. A is the right option because there in the A, they have only shown the half cycle and the direction of the EMF has not changed. The question number 33 is showing up on your screen. Three pieces of equipment made of magnetic material listed: a core of the transformer, okay, the needle of a compass, the iron filings used to show a magnetic field pattern. Which pieces of equipment act as a temporary magnet when in use? The core of the, sorry. No. The one, number one and number three. They are temporary magnets. The needle of a compass is a permanent magnet. Okay. So 1 and 3. 1 and 3. Which piece of equipment acts as a temporary magnet when in use? 1 and 3. The core of a transformer temporarily becomes a magnet. And the iron filings used to show a pattern, magnetic field pattern, they also become temporary magnets. The needle of a compass is a permanent magnet. Okay. So I think question number 33, C is the option, sir. Question number 33, C is the right option, sir. Now we are going to the next question. The next question coming up on your screen is question number 34. Students are asked to suggest factors that affect the speed of rotation of a direct current DC motor. Three of their suggestions are the strength of the magnetic field, that is true, the current, that is true, the number of turns on the coil, that is also true. Which suggestions are correct? 1, 2, and 3. They all actually increase the speed of that motor. It's a conceptual question. The speed of that motor you can increase by increasing the current, by increasing the magnetic field strength, by increasing the number of turns per unit length. So A is the option, sir. Question number 34, A is the right option, sir. Question number 34, A is the right option. Question number 35, a transformer is used to power a lamp. There are more turns on the secondary coil than on the primary coil. So it's a step-up transformer. Which statement is correct? Usually when you step up a supply, the transmission, step up means you will increase the voltage. On the secondary side, the voltage will be more than the voltage on the primary coil as compared to the primary side, and the current will decrease. So there are more turns on the secondary coil than on the primary coil. Which statement is correct? There is an alternating current in the primary coil and a direct current. No. On both the sides, the alternating current is present. There is a larger current in the secondary coil than in the primary coil. That is wrong. When you increase the voltage, the current decreases. So in the secondary side, the amount of the current is less as compared to the current in the primary coil, but the voltage in the secondary coil is more than the voltage in the primary coil. There is a changing magnetic field in the iron core. That is true. In the iron core, there is an alternating current from the primary coil to the secondary. That is wrong. In the iron core, we do not have the current which is connecting to the primary current to the secondary current. That is wrong, 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 wrong. So I think there is a changing magnetic field in the iron core. C is the right option to me, sir. Question number 35, I think C is the right answer, sir. An electric field, a beta particle follows the path shown. Which path does an alpha particle traveling at the same speed follows? Okay, the beta particles have followed this path. So if they have bended towards the bottom of the page, the alpha particles, which have the opposite charge on them, the beta particles are negatively charged. So if the beta particles, means the negatively charged particles, they have bended towards the bottom of the page, the positively charged particles will bend opposite to that. So they will bend towards the top of the page. Because the alpha particles, their size is larger, they have more mass as compared to the beta particles. So their bending is less sharp. Their bending is less sharp as compared to the beta particles. So either A is the answer or the B is the answer. I think B is the answer because this turn is less sharp and it has bended upward. So I think question number 36, B is the right option, sir. Question number 37. Which row gives the sign of the charge on the nucleus of an atom and sign of the charge of an electron? The nucleus has two things in it. It has neutrons, it has protons. Neutrons are neutral, protons are positive. So the nucleus of an atom overall is positive, and the charge on the electrons is negative. Such an easy MCQ. Charge on the nucleus will be positive. The charge on the nucleus will be positive, and the charge on the electron is supposed to be negative. So I think D is the option, sir. Question number 37, D is the right option. Question number 38. An isotope has a half-life of 6,000 years. How much time passes before the count rate due to the emission from a sample of the isotope decreases by 1/16th of the initial value? The half-life is given 6,000 years. Okay. So normally in our class, we go like this. Let's say at the start, the count rate is n naught. After one half life, it will become n naught by 2. Then it will become another half life will pass by, and it will become n naught by 4. Another half life passes by, and it becomes n naught by 8. And then another half life passes by, and it becomes n naught by 16. So count these gaps: 1, 2, 3, 4. That means 4 half lives have passed. So the total time passed will be 4 multiplied the half-life, 4 into 6,000, that is 24,000 years. So we think that 24,000 years have passed. So I think C is the option, sir. Question number 38. C is the right option, sir. This is how, in my class, this is how we do these questions. I hope you understand this great. After every half-life, the count rate becomes half. Okay. So then we have the question number 39 coming up on your screen. It's a fact which they have tested. What is the approximate time taken by the light from the sun to travel to the earth? It's a famous fact, and you need to remember this. The light takes 500 seconds from sun to earth. It's a fact, and the Cambridge wants you to remember this. So I think D is the option, sir. Question number 39, D is the option. So you have to keep this fact, okay, in your memory, sir. Now we are on the last question, which is the question number 40 coming up on your screen. So their question is question number 40. Where in the solar system is the asteroid belt? Okay, so let me show you. I have drawn that diagram. So this is that diagram. So we have Sun, Mars, Venus, Earth, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So here between the Mars and the Jupiter, we have the asteroid belt. Between the Mars and the Jupiter, we have the asteroid belt. So between the Mars and the Jupiter, so this is the C part, question number 40. I think C is the right option, sir. So let's check question number 40. C is the right option. So this is how we have solved it. And we are done with this paper, sir. And let me, okay. So my dear students, in this video, we have completed the May-June 2025 Cambridge O-Levels Physics 505412 paper. And this paper was about the MCQs. I have tried my best to explain you all the concepts according to the best of my knowledge, my abilities, my skills. So if you find this video useful, if you find this video interesting, please like this video. Please share the link of this video with your friends, with your junior students, with your senior students, with your teachers. This video can be helpful for the new teachers as well who are learning how to teach the Cambridge. So also share the link of this video on your WhatsApp, on your TikTok, on your Facebook, on your Instagram, wherever the link you can possibly post. You see, when you do this, you actually help me, you support my work. Your support is very important. Also, don't forget to subscribe to my channel. At the end, I want to tell you the paper and the marking scheme which I used in this paper, they are the property of the Cambridge. Thank you very much, sir. Have a good day. God bless you all.